separate out pigments. We separated the pigments, they like landed at different places, etc. Okay? What is the reason, the second reason for how they separate out? Yeah, I said size mattered, and I also said solubility mattered in the salt. Okay? Now, the process is called paper chromatography. Separate the pigments. We could simply have a picture of something, don't memorize necessarily the one you did, circle a pigment and ask you about its size, etc., kind of like what you did, in this DNA lab. Okay? We did this one using the magnolia plant, which I don't think that's going to be a big deal tomorrow, but just in case it shows up. And then we cut up the pigments, and we put them in little beakers, and we attempted to do some spectral analysis, but it all went like haywire in the end. Okay, and what I told you to do was go online and find the graph that showed the absorption spectra of those pigments. And about half of you did it and answered the question correctly on that lab sheet. You go online and it will show you the absorption spectra for the various pigments that we had separated out in that strip. Okay? And the pigments were based on a spectra going from all the way through, it was red, orange, yellow, green, blue, indigo, and violet. So this was the whole spectrum. And the issue is for any given pigment that we have, where does it absorb, what wavelength does it absorb the best? Whatever pigment you're looking at. And so if you have a graph, and that graph is like this, what nanometers does this pigment absorb the best at? You look, whatever this is, and you gotta be careful. The question asks you for color, you write down what color. Okay? If it says what's the size of the wavelength, you read the graph. You don't have to memorize this. You just read the graph. And I think for ours, we looked up chlorophyll A. Chlorophyll A hit right at 425, if I recall. So if you got 425 as your answer, you looked up the right, you read your graph right. Okay. Now, it may be that there's not another pigment listed in there too. Or what if the question said which wavelengths? Because sometimes they double peak. Sometimes they peak here and here, and you'd have to look and see where that one is as well. So just what I'm saying is, it's not going to be a hard thing to do. Just be very careful when you're reading the question. The question could ask you for color, or it could ask you for nanometer, or it may ask for more than one. Where is it peaking twice, or which wavelength absorbs the most? But other than that, there's probably going to be graphs on top of each other with the different pigments. You got to know, hone in on which pigment the question is asking you about, find it. Okay? There will be no running of the Spec 20